Welcome to the second part of our awesome webinar series with Cisco. Last week it was about transformations and how to transform, and now I can switch to how to transform an organization. Today it's more about cloud native operating models, which is a part of a transformation. And next week it's about Kubernetes and Cisco's solution around it, which will be done by Sebastian. And let's get started. If you have questions, just add it in the chat, and I hope I will answer it at the end because I can't see the chat window. If that's something urgent, someone needs to scream. But feel free to just shout. I'm fine with that. Nice. So we will start with a bit of history. History is always good because it eases up the whole thing. This is a castle, medieval world, and as you can see, there is a village and there is a small village somewhere in the middle. When in the past someone wanted to invade an area or just a castle, for whatever reason, doesn't matter. There are multiple ways of doing it. At the beginning, the invaders try to just run in front of the castle and try to knock it somehow down, climb up the wall, whatever. But a lot of the invaders got slaughtered, killed, and then of course it was not hugely successful. Then innovation came along in the form of, let's find other ways of doing it. So they tried to occupy the space around the castle. So they were sitting for ages and trying to basically try up supply chains into the castle so that people would starve to death or will come out and basically wave the white flag. Then the next innovation came, the castle owners, let's put it that way, they were digging hidden tunnels far beyond the occupants, and so there was a constant flow of supply into the castle. So they wouldn't starve to death, and both sides would get only shitballs. So that didn't fly too well. So the invaders had to do something to basically invade this fucking castle. What they did, they built villages. Why did they do this? Village life is perceived as something nice and beauty. You had bars, drinks, festivals, music, things like this, everything basically which makes a life. But inside the castle, of course, when you are invaded or close to be invaded, then it's kind of boring. So they wanted to show the people in the castle, outside the castle, it's quite nice, it's awesome. And this is basically about today and the whole transformation. I can't click a button. So these are the new castles, corporate campuses. The villages around are different things, new ways of working, DevOps, cloud native, Kubernetes, all of that. The invaders are not, of course, someone. It's usually other companies, startups, challenges, and they try not, of course, to invade these castles, but there is a kind of war. It's war for talent, it's war for market share. How does it look like? Well, there are new villages everywhere. Each technology sector, each sector in itself will and is already or will be disrupted by so-called challengers or just easy startups. A taxi industry would have never guessed that they would be subject to a huge change by Uber, or the hotel industry by Airbnb, financed by Monzo, N26 and Starling and the like, and so on and so forth. The list will get longer the longer we wait. But have all these in common? Well, they use tech. Tech is their competitive advantage. They manage to basically deliver value constantly at any point in time they urge to do so. On the other hand side, traditional companies using old processes and old ways of operating and old ways of doing things can't compete with the amount of change and how rapid they should do it, and will lose over time value because the other ones are coming. Over the course of time, usually the challenges of startups are not a competition. They are not perceived as such until, well, they start to gain market share. And if they start, it's not like slow, then it's really fast. They can build up companies really, really fast because they have more or less unlimited amount of funding, or can get a unlimited amount of funding. If they see basic traction and can show basic traction by disrupting a whole sector, VCs are happy to pour in as much money as, well, they can or want. And by this, these companies become your new invader. We talk about a specific village. These are all villages, but the yellow one today, which is SRE, and why that can help you compete your invaders by building internal villages. SRE, where does it come from? SRE is kind of coming out, or was developed by Google in the early 2000s. They can't put a concrete date out, but it was somewhere there. It's an independent development and has nothing to do with DevOps, with the DevOps movement, even though a lot of the DevOps philosophies are embedded in DevOps. It just happens that it's kind of coincidence, more or less the same time. DevOps was coined 2008, and they are more or less at that same time. The main difference is SRE prescribes how to succeed in these areas, whereas DevOps is a cultural term. It's about culture, automation, lean, measurement. What was the S of counts? I forgot about the S, doesn't matter. But it's not telling you what needs to be done to achieve a certain level or be successful in any of these principles. SRE, on the other hand, is prescriptive. That's why SRE is a job title, DevOps isn't. These are some of the more prescriptive measures. It's about metrics monitoring achieved by SLOs, dashboards, analytics, and of course, you will always be able to dig further down to really get to the details how to do it. It's about capacity planning using forecasting. It's demand driven and not just upfront spending a lot of money. It has performance always in mind. There is a release process. There is design which consults decisions. So you have design principles. Of course, it's about automation. Then it's about emergency response, how that works, how on-call should be done, how postmortems and analysis of incidents should be done, run books, all of this, but it's described and you need to do this. You need to have it in a variation, but you should do it. And then an underlying culture, it's about toil management, engineering alignment, and of course, I don't even know if it's a word, but blamelessness. If not, I coined it for future reference. No, I can't get further. Now, in a more detailed way, modern infrastructures are highly service-oriented. They grow more complex, and it's proven that applying software principles towards managing them, as well the software in itself and the architecture, is a boost in productivity, reliability. What SRE basically do is they offer operational support for services and platform, but it's not the typical dev to ops. So it's not like throwing an app on part of your infrastructure to an operations team, where there's no insight, no saying about anything, and just take it over and hopefully keep the lights on. There are rules. One of them is the operational work, which is keep the lights on, update, multiple things, must account for less than 50%. Everything beyond is unhealthy, and the team who is, if it's an application, then the application team needs to fix that so that the work goes down on the SAE side. Same goes if it's the infrastructure, then the platform or infrastructure engineering team needs to work towards lowering the ops work, so repetitive tasks and things like this. It's also not this, something gets thrown over the wall of confusion and then someone has to manage whatever gets thrown over. It's an optional thing. So they may onboard if they pass an assessment. We call it production readiness review, but each SAE team basically has criteria defined which an application or an infrastructure part needs to pass in order that they are able to onboard. In this review, usually things get just assessed, inspected, and then it's easier. Of course, we can already start. Here's a backlog, things you need to fix in order to increase reliability, or if there are your reliability gaps, please fix it, and then we can onboard and then do 24/7 or whatever. If you break on any of the underlying rules, SAE teams have the possibilities to give back the pager, which is just literally spoken the pager. So the on-call rotation will change. So the team, like your app team or your platform team, has to take care of their own stuff because it's unstable and unreliable. And well, they broke basically a contract. They only get it back, take it back when things are remediated. So there is a common incentive to work towards reliability. This annoys me. Okay, how do these two different teams compare? In the past, we always talked about DevOps, of course. The DevOps team is usually this cross-functional team with the so-called T-shaped people, which means deep knowledge in one area, broad knowledge, whatever the team might do, that's usually more than just one thing. On the other hand side, the SAE team is an engineering team with focus on reliability. So engineers, software or system engineers, but knowing how to build reliable systems. A DevOps team usually is doing end customer projects. If you are a DevOps team working for e-commerce application or company, you usually are responsible for a certain part, and your job is to either add new functionality or improve existing functionality. So that's end customer facing stuff. Or if you serve internal customers only, then these are your end customers. The SAE team, on the other hand side, is purely doing engineering or platform engineering projects, improve certain things, work on improvement of the platform or the application itself. And this is the other 50%, so the not ops part. In normal DevOps-ish setups, it means if you build it, you will run it. So you develop your application, you do the 24/7. The SAE team can be more compared to classical ops, but it's not the classical ops. It's just mentally more or less the same. They run stuff for others, whether it's infrastructure or application. The DevOps team focus entirely their automation on delivery. Pure CI/CD. How fast can I get my code from ID to end customers in a safe and reliable way? Whereas the SAEs are focusing on how to make this operable. So how can I automate most of the ops tasks away? What needs to happen that it's reliable? All of this. This is the automation focus of that team. The KPIs of a DevOps team usually are business metrics, conversion rates, users, things like this, things which are more important for the business than for the SIEs. They are more driven by service level objectives, error budgets, number of pages, things like this. That's their KPI. The DevOps team optimizes lead time and checks that value is delivered. Value is only delivered when it's basically delivered to production, so someone can consume it. So that's their optimization. Usually something like value stream mapping and stuff like this happens in the DevOps team. On the SAE team, number of pages, operational load, mean time to repair, all of this NTT and X, that's basically the SAE team. Then the DevOps team usually develops 80% of their time, it's development, and usually they tend to do Scrum. The SAE team, 50% is operational work, 50% is pure engineering improvement, things like this, usually Kanban. Mouse. But why? I mean, why is it gaining popularity? It started at Google, as I've said, and in the last years, Google started to publish 3 books, which was exactly about SAE. That was already a boost. And then, of course, former SAEs of Google changed companies, speaker conferences, write blogs. So it becomes more of a movement like DevOps. It was for a lot of years a Google thing. And now it becomes more, and it's, well, more known, and it becomes a movement in itself. But why should someone go back away from basically you build it, you run it, like DevOps? Quite simple. A DevOps team is usually quite small. It consists of 5 to 7 people because the scope is limited of the responsibility as service or some small services, but the whole team should get it in their head for what they are responsible. That's why it's usually narrow focused. Jeff Bezos was it, I think, who coined the 2 pizza team. That basically means you should feed your team with 2 standard pizzas and not cheating with 2 big American family pizzas, standard pizzas. And they should do 24/7 ops. So what can go wrong? Let's say you have a team of 5, so somewhere reasonable sized DevOps team they are capable and willing. Willing is important because a lot of people don't want to do 24/7 to handle on-call duty. Usually the usual setup is 1 is primary, 1 is backup. So you have a rotation policy. If an alarm is fired, the primary engineer gets paged, whatever. You set it up, that's up to you. Apps, calls, SMS, email, all of that, whatever. If the alert is not acknowledged, it automatically gets after a defined period of time to the backup, and then the same thing starts over. That basically means that everyone is on duty 146 days a year, almost each second week. Even though you might not have a lot of alarms, but by just carrying a phone with you because you're obliged to, because you need to, it's an impact. It's an impact on your social life. And then if you get paged, for example, during the night, even a small one, a 30-minute interruption. So I get up, acknowledge, fix it within some minutes, and then get back to sleep. So 30-minute interruption, they basically lead on the next day that I'm less able to concentrate for doing my day job. My day job is delivering quality work, code, features, improvements. So this lack of concentration will lead to less quality, which leads to more alerts, which leads to more pages. So it's going on and on. Then even during the day, usually the team is during the day responsible as well for incoming alerts. Alerts not only happen during the night, so while coding, you get interrupted. So what a lot of companies do is they say, okay, we have a incident manager of the day or something, so someone who exclusively takes care of all the incoming alerts during the day. Either the productivity of this person is quite low, or you remove him or her entirely, so the whole team productivity suffers and less value get created. It's a real problem. That's why the former dev and ops thing was not right, because shit gets thrown over a fence and a wall, and others had to take care without understanding. SAE tries to fix that. So it's someone else takes a kind of care, but only kind of, because there are joint responsibilities which were missing in the past. But you can focus on value delivery within certain borders. The SAE team will take care of reliability and keeping the lights on. The guiding principles of SAE are the ability to regulate their own workload. That's done. I will explain all of them in more detail. Service level objectives with consequences. Time to make tomorrow better than today. Failure is an opportunity to improve. How does that look like? Before I start, glossary of terms. A lot of terms will now be thrown at you. We mainly talk now about SLOs and SLIs, and SLO is a service level objective. That's a top line target for a fraction of good interaction. As an example, 99.95% of well-formed queries will receive well-formed responses. Okay, fine. At least the techies can grasp it. The SLI is basically a service level indicator that's end user facing. So that's the measurement where I say what is good enough for my users, or basically what's the acceptance level of user pains. They consist usually of multiple SLOs, and then you form an SLI, as you can see on this one here, 2 SLOs, 1 SLI. And the SLI is basically an indicator for my user pain. Then there's this thing called error budget that became really famous when the first SAE book was published. You read more or less all over error budgets, error budgets. What does it basically mean? You shouldn't use the SLO as a 85% uptime thingy. So I need to check that basically this happens. You should revert it, which means I have budget. It's a 0.15% error budget. I can use that for anything because we kind of agree 99.85 is summed up. So I can mess with the 0.15%. It's basically as well the discomfort. This is basically as well what I accept that my users accept it. So if I am 0.15% of the time down, well, it's acceptable. At least I expect that my users accept it. How these numbers are created, usually you involve the stakeholders. That's the, depends. If it's the app team, then usually it's the PM, PO, then the SAE, the PMO is usually the stakeholder for the end users. So he or she can say, well, it's enough to be 99.85% available. Whatever you do, please make that happen. And then what is basically the joint responsibility is the 0.15% is basically should be used for multiple things: innovation, UIDs, early releases, to try things out. And a lot of things can be done with 0.15% over the course of 30 days. But if it's blown up, so there is no budget available anymore, release freeze until the budget is replenished. It's important that with make it public, I mean consuming parties. It's not necessarily that you should put it on your website. For end user, doesn't mean usually a thing, but you should, if you are a service provider which is consumed by other services, then the other service, the consuming party, should be able to know what to expect from you. The biggest benefit of working with error budget is that it's an incentive for everyone involved in making this happen. So this is basically the balance between innovation and reliability. Often the discussion is about features versus technical depth. Here you have a percentage to work towards. If you pile up your technical depth, each basically sliding window of 30 days will basically be blown up by the technical depth you pile up. So you have an incentive to maintain your technical depth because reliability is important. On the other hand side, teams can manage the risk themselves. If you accept that, well, over the next, I don't know, 60 days, I'm fine with piling up technical debt so that the reliability goes kind of down. It stays within the boundary, then it's fine. The team is responsible, no one else, to basically tell you, you should do this or that. Also, it is part of a sprint planning or whatever. It's features versus depth, how you want to spend this budget. If you have unrealistic goals, you will immediately feel the pain which comes with it. I come with too high and too low. I will discuss this later. Teams usually then create own policies around their SLOs, how to spend it, under which criteria they accept to spend something if things go wrong, things like this. So they create their own policies. No one needs to care about this. But it's important to understand it's a shared responsibility. So it's not like only the app DevOps team has this error budget. If the SRE team, for example, blows up something, it's a shared error budget. Collaboration is key. If the infrastructure blows up, error budget gone. In worst case, no feature released. So work together, small batches, small changes, things like this. SLOs with consequences. There are only a handful of systems I can think of, and I only found 3 where 100% or close to 100% availability is required, or you should aspire to. Rockets, because they shouldn't blow up when starting, and they should be able to return from wherever they are. Medical devices like the heart stimulator, I expect if I would have one that this fucking thing continues to run, and it's not like 90x% or let's test new features. This thing needs to be rock solid. 5 different availability things in it to basically countermeasure all occurrences of weird things, and nuclear plants. None of these, on the other hand side, need to aspire for 99, 99, or 100%. But if you would go to NZZ, Adidas, or I forgot the name of this stupid game, doesn't matter. Usually the first discussion is about, wow, we need a shitload of 9s. 5 to 10 9 availability, that's at least required. No, because usually your end users can't tell the difference between 199.999, and I would even go further. They can't differentiate between 5 9s and 3 9s, 2 9s and a 5 or something like this. So you should be realistic. If you only want to publish news, well, maybe even 98 is fine because there are costs involved in this. A good example is Chubby. Chubby is a distributed log service at Google, and I don't know when it was. I forgot to look that up. Chubby was consumed by a lot of other services, and the problem with Chubby was it was all the time up. It was highly reliable, but they didn't put an SLI on it, and nothing. So people relied, and the longer basically the service was up, the tighter coupled was Chubby into the other systems because they relied on it. One day, Chubby blew up. Chubby in itself was kind of treated from the team as a best effort service. So they didn't have a problem. They fixed it, and after a couple of hours, it was back. The problem was there were reliant services. So within Google, it created a huge clusterfuck. A lot of high available services were basically down because they were too tightly coupled. Now, of course, SAE took over Chubby as well. And now the other practice comes into play. If you do all the things, you do experiments, you play with new tech, you release features early, and you still have always plenty of SLO or error budget left, you can do two things: either adjust your SLO or control outages. Outage, I will come to how to basically blow your error budget by intent later. The cost associated with too high or too low are tremendous. If you put a too high SLO in place, each digit basically accounts for at least double to quadruple of the price associated. Something fell down. Associated with the infrastructure, the way you need to develop, more excessive testing, and all of this. So the more reliable you are, the more restrictive you get, and the more systems you need. So the costs are enormously high. And then the same problem like with Chubby happens, that dependent services usually get tighter coupled because, well, it's reliable, so why should I put countermeasures in place? Usually when you work on a system with 5 nines or more, it's quite frustrating because you can't get shit done. So only do this if you really need it. On the other hand side, if it's too low, of course, you will have frustrated users, churn of users, they turn away to other service providers, things like this. The cost usually on too low comes by other practices. Usually, if you have a low level of reliability, you have expensive workarounds in place by others, by the ones who want to consume it. Sometimes they duplicate your functionality. Often a lot of manual processes are still in place, which lead to this low level of reliability. And well, frustrated users, no one needs that because they definitely turn away. What is required if you, the first two parts, more or less everyone knows, that's basically 99%. You basically almost have 6.5 hours to do something until you basically are below this SLO. You don't need anything for 99%. You can let your users call you to basically then fix eventually the issue. As soon as you get a bit up higher, you start already needing comprehensive monitoring and 24/7. That already increases complexity. Comprehensive monitoring means I need to export metrics, I need to export logs, I need to centrally store them somewhere, process dashboards, a lot of things. So complexity already increases. And I need a 24/7 on-call. I need people, ideally 5 to 7, to manage that properly, mental health, all of that. 99.9, only the time gets smaller. More investment in proactive monitoring, so it needs just to be better than at 99.5. No new tech, but the complexity increases by more monitoring, more logging, more proactiveness, and 24/7, which works. If you go already slightly higher, 99.95%, it's just 21 minutes within 30 days. You can't play around with that time anymore. The moment you receive a call, then you need to get out of bed, go to your computer, log into a system, basically your budget is blown. That's unfeasible. You should, basically, you need to have automated rollback. That means a lot of technical requirements need to be ticked to be able to automatically roll back in a safe way that's a cost associated. There's a lot of cost in it. And a lot of companies, when we talk about basically this, that's the wish. And basically what they have is this. Not even proper monitoring in place, but everyone, when it comes to contract negotiation or something, we need a lot of nines, but do you have this? Do you have the budget for it? Can you build it? Can you do it? No, usually not. 99.99 minutes, well, percent for minutes, automated rollback. No other way for doing something within 4 minutes. I'm sometimes not even able to hit the button on my phone to acknowledge an alert within that time. I need to first get my thoughts clear before I do something. And then the mystical 5 nines, a lot of companies try to aspire it. It's only 25 seconds. No other way than not even trying to roll back. You need to have active sites to serve all the traffic constantly. And with failover, I mean just one site or something like a whole AWS or Google or Azure region goes off. The other need to serve still the whole traffic. You need to be able to cope with huge outages live. No like rerouting of traffic. The traffic needs to continue, and usually then auto scaling needs also to be in place to potentially scale the other regions if there's too much traffic to handle it. Continuous improvements to basically get there. The most important part, blameless postmortems. It's not about who basically blew the error budget or blow something up. It's about why was it even able to blow it up? Why could this incident happen? If I, for example, did something and it blew up the infrastructure or the application or whatever, why was I even able to do it? This should have been prevented by countermeasures firsthand. Often they are not existing, that's fine, but then put them later in. But it's not about who, it's about how, and then fix it permanently. There's nothing else than automation. Other teams communicate via API and API contracts in place. There needs to be GitOps. In earlier days, you would have called it infra as code, but let's stick to GitOps, test automation, and continuous delivery. You can't do things manually anymore. A failure is an opportunity to improve. That's why you should do them artificially. Blow your infrastructure. Netflix came up with Chaos Monkey. It's an open source tool. There are plenty of others. More Chaos Monkey is kind of the more known one, but there are pretty good, solid open source ones, and now are also commercial SaaS platforms. What it basically does, it forces decoupling between services. If I randomly blow up my part, first I know what happens, then I can work toward on the reliability that if this service blows up, that dependent services are not blowing up. And then I also find weaknesses in architecture. There are single points of failure. I will then identify a lot by doing this. There are kind of multiple stages of getting there. So in chaos engineering, it's not like you need to run this always from day one in production, but that should be your target. At the beginning, try it in test environments and then go closer to production until you do it in production. Netflix is doing it all the time, each day in production, and sometimes shutting off whole regions. And it's not just one, it's then multiple regions as one to see how, for example, there can fail over. Small summary, but we are not done. SAEs automates operational tasks. Everything which is associated to ops should be automated so that it does not account for more than 50% of the work. SAEs run infra and apps, applications use error budgets for innovation and resiliency, operate for other teams if they are well engineered and passing a PRR. Other names fly around, that's ours. They take it over if they don't produce an unreasonable amount of pages. Also, SAEs want to sleep, even though they get paid that they get up. They will return the pager if you basically break the social contract in place. What you get, you keep your users happy, you build reliable systems, you manage the innovation reliability tension, features versus stability or technical debt. They maintain all the things, you can maintain all the things. And by this, you manage conflicting needs. This is a question we sometimes get. We have ITSM and ITIL, we can't even do DevOps because of this. ITIL is 20 years old. It's a fucking complex beast. It has 4 dimensions, 7 principles, and 34 practices. No one ever needs that whole thing. Google refers to SAE as its approach to service management. And the key areas of SAE kind of match the ITSM framework, ITIL. A lot of things are not there. There is no cut on change the trial report or the like, because it's not required. You should automate. But you can use SAE to replace your ITSM processes or ITIL mainly. Reliability is the most important need for an application running at scale. If you have end users and you want to scale, you want to make your users happy and prevent them from running to other villages, then, well, you need to be reliable and you need to be able to create value at each point in time, fast, automation, CI/CD. SAE is Google's approach to run production systems in a way that balanced this whole thing. We at Container Solutions offer this as a service. So we do SAE as a service, we call it then CIE, and where we apply these practices and well, offer it as a service. We operate all kinds of systems and we help with scalability, reliability, all these T's. By this, we guide system architecture, help you to build reliable systems. We use whatever we learned in the last 6 years. We hope for the best, but plan for the worst. We have all incident management processes in place. We do all kinds of things to ensure that SLOs are met, but not overdone. So we use also our error budget at customers. Basically, at the end of a transformation, you come from waterfall. If you go cloud native, you have a DevOps team which basically does something either with a platform or application, and then you have an SAE team which manages it. We have written some books. SAE on the left, then Cloud Native Transformation by Pini, who was last week speaking here, and Jamie and Michelle about how to make a transformation happen. Using the QR codes, you will get this recording. You can use then the QR code to either download the free ebook or get information about client reliability engineering. And now, questions, please. Otherwise it gets boring.
Hey, Michael, can I have a question?
Of course.
So for someone who is using two terms like DevOps and SRE, like exchangeably, like without knowing the difference, what's your like very simple explanation how to draw the line in the sand, how to distinguish both?
SRE is a job title, DevOps isn't. That's the first thing, because DevOps does not prescribe what DevOps is, so how can it be a job title? SRE is basically what you formerly had. You had Dev and then you had Ops. Ops was taking care of uptime and keep the lights on. This is kind of still true, just with all the social contracts and rules in place that you basically manage jointly targets. But your Dev DevOps team, however you want to call it. You can call them DevOps team, or application developers or platform engineers can focus on value creation. Either it's application development or platform engineering, providing you with managed CI/CD or the like, and further develop that. And the SRE team would then just take care of reliability of these two things.
Okay, that makes sense. Thank you for this.
More than welcome. If no one has questions, or is there something in the chat? I don't think so. Huh?
No, we are thanking you for the presentation, though.
More than welcome.
Perfect.
Then I leave you to it.
Yeah. And I'll see you all next week, hopefully, and have a nice day.
You too. Bye.
Bye-bye.